Okay, so I'm going to explain how to do today's homework. You are first of all going to answer the multiple choice questions on the first page. There are 7, and you should use your notes in order to do this side of the homework. Particularly this set of notes will be really helpful to you, the doodle notes that we kind of colored in and took together this week. But all of your notes will be helpful. When we flip to the first page, or the second page, excuse me, we're going to practice drawing atoms. You're going to use your periodic table, which is this, okay, and the information below to determine the number of protons, neutrons, and electrons listed and list them in the provided boxes. Then use the information to draw a diagram of your atom within the provided atom box. For protons and neutrons, you can just write 7p or 8n. So you can write a number followed by p for proton and a number followed by n for neutron, indicating the number of neutrons in the nucleus. So for example, neon, our first one, we would look at the atomic number right here. The atomic number tells us the number of protons. So that's 10. And we would write 10p in the nucleus. We would then assume, because it's not stated otherwise, that the atom is neutral, which means the positives and negatives, the protons and electrons, are equal. So if the protons are 10, then the electrons would be 10. And then it tells us that the mass number, so remember this is protons, so it's giving us specific mass number, that's our protons plus our neutrons, is 20. So remember, when we want to obtain or figure out what our neutrons are, we take our protons and neutrons and we subtract our protons. So 20 minus 10 is 10. Okay, so we would fill in 10 neutrons in the nucleus. And then to figure out the electrons, we would look at our periodic table, and it tells us for neon in the first ring, there are 2 electrons. In the second ring, there's 8. So we would, in the first ring, put dots for electrons, so 2 in the first ring, and 1, 2, 3, 4, 5, 6, 7, 8 electrons in the second ring. Okay? For the examples below, or for these problems below, I'll do one with you. The first one is sulfur. It says, use the information provided for each element to complete the diagrams. Fill in the number of protons and neutrons and draw dots for the proper location of the electrons. Make sure to use your periodic table. For this one, it tells us the atomic number is 16. That means that's the number of protons. The mass number, that's how much the atom weighs. It's a specific isotope, so we don't have to look at the average weight. Given all the isotopes, we're looking at a very specific form of sulfur that weighs 32. That's the protons plus the neutrons, okay? So next to P for proton, we would put 16. That's our atomic number. For our neutrons, remember we take the protons and neutrons and subtract the protons. So 32 minus 16 is 16 for the neutrons. Okay? Then we're going to assume that this is neutral because we're not told otherwise, which means our protons will equal our electrons. Our positives will equal our negatives. And we go to the periodic table and find sulfur. Sulfur's right here. It tells us there's 2 electrons in the first ring, 8 in the second, and 6 in the third. So we've got 2, 8, 6. So we're going to put 2 electrons in the first ring. We're going to situate 8 electrons in the second ring. 1, 2, 3, 4, 5, 6, 7, 8. And then we're going to put 6 in the third ring. 1, 2, 3, 4, 5, 6. So that's how we do this set of problems. Now, when you go to your last page, okay, the information that you need to know is that the dark dots in the nucleus are the protons. The clear or white dots in the nucleus are the neutrons. And then in the rings, those are our electrons. Okay, so when we're trying to identify the element, as we've talked about, we look at the number of protons, the atomic number. Okay, so we're going to look at the atomic number, or the number of protons, and we've got 1, 2, 3, 4, 5, 6 protons in the nucleus. Okay, so we're going to go ahead and find atomic number 6 on our chart. It tells us that that is carbon, because remember, our proton number never changes. So the type of element is carbon. Now we want to find out if it's electrically neutral. So what we want to know is, does our number of protons equal our number of electrons? If I'm neutral, my positives will equal my negatives, and they'll cancel each other out. So as stated before, we counted 6 protons, 6 positives, and then now we're going to count our electrons. 1, 2, 3, 4, 5, 6. There are 6 negative electrons, so those would cancel each other out, and we would get 0 charge. So is the atom neutral, which means 0 charge? And the answer is yes. How do I know? My number of protons equals my number of electrons. Okay, so those two numbers are equal. The positives equal the negatives, and so they cancel each other out. And you would continue on like that for the rest of the problems on the homework. Good luck.